All right, Calculus, Lesson 2.6, Part 2. All right, so we have a ladder. It's 25 foot long. It's leaning against the wall of a house. The base of the ladder is being pulled away from the wall at the rate of 2 foot per second. It says, what is the velocity at the top of the ladder when the base is 7 foot from the wall? So we got to understand this, but this ladder's like that. This is always 25. This height right here is decreasing. This distance right here is increasing. It's being pulled out that direction. So here's our picture for our X, Y, and our 25. What am I given? See, I'm given the ladder's being pulled at the rate of 2 feet per second from the wall. So this X right here is increasing at 2 feet per second. I'm supposed to find this dy dt when the base is 7 foot from the wall. So that would mean when X is 7. My equation would be Pythagorean theorem. X squared plus y squared is 25 squared. Take the derivative, 2x dx dt plus 2y dy dt equals 0. All right, at this point on my when x was 7, Pythagorean theorem, I would get what that y is. Because see, I need to plug in for x, I need to plug in for y. I'm solving for this one. I already know that is 2. So now I'm ready to plug in all my numbers. So this right here is 4 times 7 is 28. Move it over, divide by 48, and that's the rate at which my y is changing. That's how quickly my ladder is sliding down the wall at 7/12 of a foot per second. Now that was part A of this question. All right, part B of the question. Consider the same scenario. The triangle formed this time. Find the rate at which the area is changing. So same exact story, except this time it's area. So again, I'm still given the dx dt. I need to find dA dt though. When x is 7, the equation of the area would be equals to A equals 1/2 x times y. I have 3 variables right here. We do not want 3 variables, remember. So when we have 3 variables, we need to do something about that. So if I go ahead and solve, I'm going to solve that the area with respect to time, coefficient's 1/2, x, y, I had to use product rule. So this is using the product rule. Now, y'all, what happened here is I knew dx dt. This is the same scenario as problem A. In problem A, we found dy dt. That's why I didn't worry about getting rid of the extra letter this time, because I know my dy dt. So again, in part A, we found the dy dt for the same story. So now all I have to do is plug in all these numbers. We also already did our when. This was 7. We also found that to be 24. And now we literally plug in all those numbers and we will have our answer and how quickly the area is changing. Same story. So we know dx dt, we know dy dt, we know the when x is 7, we know that y is 24. Let's see what we need to do here. Now it's saying find the rate at which the angle between the ladder and the wall of the house is changing. So this time I want to know this angle between the house and the wall. So as this is going out, isn't that angle getting bigger? See, as this goes out, the angle down here is smaller. Alrighty, guys. So we're given the same dx dt. We also know dy dt if we need it. Find d theta dt when x is 7. When x is 7, we also know y is 24. All right, the equation this time, I got x and 25. The sign is x over 25. This derivative would be cosine, I'm sorry, they didn't do that yet. We did coefficient of 1/25 x. The derivative of the sign is cosine theta d theta dt. That's what I'm looking for. This derivative, 1/25 dx dt. So there's dx dt. Cosine of theta, well, off of my when, cosine of theta would be 24 over 25. So that's 24 over 25. That dx dt was 2. Multiply both sides by its reciprocal, and there's my d theta dt. And that'll always be in radians per second. That's not going to be in degrees. These will always be in radians when we talk about the change in an angle measure. It won't work correctly with degrees. So in lesson 2.6, you really need to get memorized given, find, when, and equation. This is very important with a picture. All right. Try to do these different ones. This is the very first problems that you do, please, to make sure you kind of got the concept down. I hope this helped you guys out. You have a great day.